All right, we are covering Chapter 2, Section 4, Properties from Algebra. So some of these properties you guys have seen before. It's mainly just kind of a review. Some of them may be new, some of them you never learned, but we're definitely going over it. You need these properties. You need these properties. We are kind of starting like a little proof section, but proof section using algebra. Okay, so these are going to be a little bit on the easier side. Once we get into more geometric proofs, it's going to get a little more challenging. So please stay with me. Please focus on these. And then when we get to geometric proofs, I'll try my best to explain them as best as possible so everybody is together and nobody's confused. However, properties of equality. You have addition, subtraction, multiplication, division. We know how to solve equations. We know how to solve them. But now we're giving more of reasons and vocabulary behind what we're doing. So if you didn't already know some of these, I know maybe you guys have covered it in middle school briefly, but you have to know it for your properties, for your reasons, for your proofs. So addition property, if A equals B and C equals D, then A plus C equals B plus D. What these mean is when you're solving for a variable, when you're solving for something and you have to move it to both sides of your equal sign, that is what you're doing. So for example, if I have 2x plus 16 equals 24. In order for me to solve for x, I have to get rid of that plus 16. How am I doing that? I need to subtract 16 to both sides. That is called subtraction property of equality, when you are moving something to both sides of the equal sign. So let me just, again, give you that example. If I have like 2x plus 16 equals 24, if I am subtracting that 16, that step of subtraction to get to my next answer is called subtraction property of equality. I'm moving it to both sides of the equal sign. So that's the same with all of these. For addition, subtraction, multiplication, and division, it just means you're moving it to both sides of the equal sign. So I am going to go ahead and write that on here because that's something that we can kind of identify and understand rather than looking at all these words and letters and saying, what the heck is this? So when you have addition property of equality, I'm just going to write property. That means you're adding, you have subtraction, property, you're subtracting, multiplication, property when you're multiplying, and then you also have division, property, and you are dividing. Those properties of equalities is when you're doing the same thing on both sides of the equal sign. Okay, when you're moving it to both sides of the equal sign, that is what properties of equality mean. You're moving them on the equal sign. So when you have something moving over, just remember it has the word equality, equal. That is property of equality. You can also shorten properties of equality. Instead of writing the whole thing out, you can write it as POE, properties of equality. So just shortening out a little bit for you, so you don't have to write the whole thing. All right, more properties. These are pretty easy. Before you start writing the notes down, just look up at the board. I'm going to read you what they are because you already know some of these. You have substitution property. We know how to substitute. A lot of students just like to say, oh, Ms. Chung, I know what that is. That's plugging in. Yes, that is plugging in, but you now need to give me the proper vocabulary. Yes, students like to say it is plugging in, but you need to write not plug in on your proof. You need to write substitution. Okay, when you're substituting something in. So if x equals 4 and they're giving me an equation with x, I'm going to plug in 4 for the x. I'm substituting my x for my 4. I'm just plugging something in. So that one we should know. Also the ones on the bottom we should know. Distributive. Distributive properties when you're distributing something. Okay, don't worry about the sum or difference. Just know what distribution is. That is distributive property. Yes, sum means you're adding. Difference means you're subtracting. That's good to know. We should already know that. But just know what distributive property is when you're distributing something. The only 3 that maybe you might have never heard of, maybe you have, maybe you haven't. The main 3 that we're covering is reflexive, symmetric, and transitive. Those are the 3, let's just say maybe new ones if you've never seen them before. But those 3 are 3 that you have to memorize. I guarantee you're going to see this on the test, and you will continue seeing these throughout the entire school year. So do not forget what these are. I have reflexive property, symmetric property, and transitive property. What are they? They're giving you an example. Reflexive property is just a reflection of itself. It's the same thing. A equals A, B equals B, line DE equals line DE. You're just writing the same thing equal to the same thing. Do not get reflexive property confused with symmetric property. A lot of people do. When I say the word symmetric, what do you hear in that word? What's another word that you can identify with symmetric? Yes. Symmetry. Good. So think of your line of symmetry. Do you remember what that is? No, we forgot. Okay, so line of symmetry. Have you guys ever done those preschool projects where you put paint on one half of the paper and you fold it? And then you open it up and it's like the same pattern on both sides? That's basically what this is. So think of it as if I have a line of symmetry here. My B's are where my B's are, and my A's are where my A's are. That's a good way to think about it. Your line of symmetry. Another way you could think about this is you are switching the order. Okay, so A equals B, then B equals A. I'm switching the order of these. So a couple things I'm going to write on the side here. Switch order. Or again, you could think of you have a line of symmetry. Okay, don't forget those. Again, do not mix up symmetric property with reflexive property. Now, transitive. Look at my transitive property. Can anybody tell me what law this looks like? We covered 2 laws. What law does this one look like? Yes. Good. This looks like law of syllogism. All you're doing is you're getting rid of that overlap. So I'm going to go ahead and write law of syllogism. And you join the statements. Okay, I'm joining them together. So back to law of syllogism, you're getting rid of that overlap. So transitive is like law of syllogism. However, when I'm writing my proof, I cannot write law of syllogism. You have to write transitive property. Any questions on these that are on here? Substitution, reflexive, symmetric, transitive, and distributive. Any questions on these properties? Please study those 3 because they're super, super important. Highlight it, underline it, do what you need to make sure you are not getting these mixed up. And you have to know what these are. All right, these are now properties applied to angles and segments. So here are my segments. Here are my angles. This is something that you may see when you're writing out proofs. Okay, so reflexive property. Again, it's the same thing. DE equals DE. Angle D equals angle D. So this would be more or less written as angle D equals angle D, not with a word. All right, symmetric, again, symmetric, think of it again as you have a line of symmetry. It is symmetrical, or you are switching the order. DE is equal to FG, then FG is equal to DE. You're switching the order. angle A is equal to angle B. So if angle A is equal to angle B, then angle B is equal to angle A. And then transitive was like your law of syllogism. What you're doing is you're getting rid of that overlap. You're joining the statements together. All right, looking at example 1, it says justify each statement with a property from algebra or a property of equality. So looking at these, we need to state what property it goes to. Looking at the first one, if AB is equal to CD, then CD equals to AB. What property is this? Does anybody have an idea? Look back if you need to. What property would this one be? Yes.
Symmetric.
What is it? Good. Symmetric property, it's symmetrical. It's just switching the order. So for this one, it is symmetric property of equality. Property of equality. All right, looking at number 2. What property is this? Yeah.
Distributive sum.
Good. Distributive sum. I'm just going to go ahead and write distributive property. But yes, it is a sum. All right, looking at number 3, before you answer, look at it. It says, if 2a plus b equals 24 and b equals 4a, then 2a plus 4a equals 24. What is happening here? A lot of people just look at it and assume that it's transitive. It is not transitive. What would this one be? Yes.
Substitution.
Good. All you're doing is substituting. You're substituting your b for your 4a, and then you're just plugging in that 4a. This is substitution property. All right, now looking at the next one. If x over 3 equals 12, then x equals 32. Do not overthink it. What property would this one be? Again, don't overthink it. Just look at it. What are you doing? How are you getting there? Yes. What is it? Multiplication property of equality. Good. I am multiplying both sides by 3. So this is multiplication property of equality because I'm doing it to both sides of my equal sign. Okay, so we're just identifying properties. Nothing too difficult. But looking at the next example, we're going to go ahead and go to justifying each step. So this is kind of like the start of proofs. They want me to justify each step. So when you are given a proof, it normally has this little T-chart. It is giving you your statements and then your reasons. So that's how it's going to look on your homework or on your tests or anywhere in the future that we continue to do these. So they are giving you your statements. Your homework, it may give you the statements looking like this. However, you need to write it out. Why? Because I want to see your work. And I'm going to show you as if you're writing it out. So it's up to you. It's personal preference. You could either go ahead and solve all your statements and then fill in your reasons, or do it at the same time. All right, looking at the first one, your first reason for any proof is always going to be given. Please do not get that wrong. Why is it given? It's because they're giving it to me. That's the first one. There is no work on how to get to the first step. It is given. Now, I'm going to look at it. I'm going to go ahead and do my statements first. I need to show my work. It'll be given to you like this on your homework. Maybe it'll be given to you like this on the test. I still need to see your work on the homework. So I'm going to go ahead and do it in a different color so you can show me the work. How am I getting from step 1 to step 2? Yeah. Good. I'm showing my work. How am I showing my work? I'm showing my work by multiplying both sides by 3. That's how I'm getting to step 2. How am I getting from step 2 to step 3? Yes, Camilla? I am now distributing. How am I getting from step 3 to step 4? 3 to 4. Good, I am adding 12x to both sides. And then how am I getting from step 4 to step 5? Good, I'm dividing. So we kind of figured out what reasons we need to give because we kind of wrote out the steps and we said the steps. So reason for step 2, please don't look at this and say, oh, it's distribution. No, it's the reason on how I'm going from 1 to 2. So what's my reasoning behind going from 1 to 2? How am I getting to 2? What did we do? Yeah. Good. So this is multiplication property. And I'm going to put POE because we multiplied on both sides. Property of equality. Now, how am I getting to step 3? What did I do? I divided. So it's just division property. How am I getting from 3 to 4? Addition property, good. How am I getting from 4 to 5? Good. Division. I put division property for 3, didn't I? It should be distribution. Oops. And then this one should be division property of equality. POE, as well as my addition should be POE. Okay. Questions on this? So when you're doing the homework, you need to write both statements and reasons out. I think Ms. Corey did like 18 questions. Out of those 18, 11 of them you have to show work because the first 11 are your proofs. It's fine, you can leave it. Yeah, I'll move it back. Okay, so you have to write those proofs out and you have to show me the work. All right, looking at the next question. Now this one I want you to try on your own. Write out your T-chart, your statements, and your reasons. I will do the first one for you. Ooh, let me fix that line. Okay, so it says solve this. Justify each step. So they are giving me what is given. Okay, they have 3x plus 2 equals 23 minus 4x. And then my first reason is always given. Do not get that first reason wrong. Go ahead and solve this. They want you to solve. And then go ahead and give me all the reasons. Again, you could do your statements first, then your reasons, or you can do them together. Go ahead and get started on this one, and then we'll come back and check. All right, you should be finished or finishing. If not, go ahead and finish while I'm going over the first few. So for this one, we could have solved step 2 and step 3 in a different order, depending on how you did this first. So I'm going to go ahead and do my statements first. But again, depends on what we did first. So a couple things you could have done. You could have subtracted by 3x, or you could have added by 4x, or you could have subtracted by 2 or subtracted by 23. So I have the job of looking over all of your work and your tests when test day comes to double check that it was correct. There's no right way of doing the order, but there is obviously a correct way on how to do the work and a correct way on how to state the reasons for the work. So depending on how you started, we may have switched step 2 and step 3 depending on who you are. So looking at number 1, can someone give me the second step? So now I'm going according to whoever gives me their answer. Sophia?
7x plus 2 minus 1.
Okay, so how did you get there?
I added 4x.
Okay, so again, all classes have given me something different, but what she did was she added 4x. So if you did something else other than add 4x, I'm not saying it's wrong. Let's just make sure we get to the same answer. So now for this one, I'm gonna have 2. I now have 7x plus 2 equals 23. Anybody else? What should I do next? Yeah, Brandon? Good, subtract 2. So I'm gonna have 7x equals 21, and what should I do last? Camilla? Divide by 7, and that gives me my last step, which is 4. X equals 3. Okay, I did that. Now let me go ahead and write my reasons. Let me just make this a little thicker. Okay. All right, so we did our statements, reasons. We're at our reasons now. How am I getting from 1 to 2? What did I do? Yes, Sophia? Good. Addition property of equality. I know I spelled this wrong. All right, how am I getting from step 2 to 3? Yeah. Good. Subtraction. Property of equality. I'm doing it to both sides of my equal sign. And how am I getting from 3 to 4? Gabriel?
Division.
Good. Division property. Again, so for your homework, you guys have to show me the work on how you're getting there. So yes, please write it out. All right, looking at example number 4, solve for R. So they're telling me where I need to get at the end, and they're giving me the formula that I have to use. So I'm going to go ahead and do the same thing as before. Write my T-chart. I have my statements, and I have my reasons. And I will do the first one for you. They are giving me the starting. So P times R plus 1 equals N, and that is going to be given. Go ahead and continue and write out the steps to equal R with your reasons. All right, if you have not finished it, that's fine. Go ahead and finish it. But I'm going to go ahead and do my statements first, and then I'll fill in my reasons. So looking at what they gave us, what am I doing to solve for R? What do I do next? Thank you. Yes, we are distributing. So then I'm going to have P times R plus P equals N. Now what do I do? Subtract what? Subtract P. So I'm going to have PR equals N minus P. Now what do I do next? Good. I'm going to go ahead and divide by P. And then I'm going to get R equals N minus P over P. Okay. Showing my work should definitely be a lot easier now when I'm given my reasons. So reason number 2 is what? What was it? Not subtract. Remember, it's how am I getting from 1 to 2? It's how am I getting from 2, Gabriel? Yes, distributive property, good. All right, now looking at 3. Now, Kamala, how am I getting from 2 to 3? Subtraction what? Of equality. Good. Subtraction property of equality. And then my last one, 4. Leilani. Division. Perfect. Equality. Yep, you're good. Division, POE. Okay, property of equality, short, POE. Questions on this one? No, not too hard, right? We like algebra proofs.
Yes.
Okay. I'm going to give you an example of a geometric proof. You do not have to write it down. Just look up at the board, please. Pencils or stylus or whatever they call these things right now, just go ahead and put them down. All right. Looking at this example, may look like it's a lot. You just have to think about it and follow certain steps to get there. So the question says, or what they want us to do, it says, you reflect the beam of a spotlight of a mirror laying flat on a stage as shown. Determine whether the measure of angle DBA is equal to the measure of angle EBC. So that's not what's given. That is what I'm trying to prove. That's what I'm trying to find. So that should be my very last step. So here is DBA. And then here is EBC. So I have to use the diagram. Looking at my diagram, what is given? Can anybody determine what's given in my diagram? What do I know? Absolutely 100% sure. What do I know about my diagram, Jonah?
EBC is equal to EBA.
EBC is equal to...
EBA. EBC is equal to EBA.
Yes, but that is not what's given. That's what I'm trying to prove. I can't go off and say, that's my answer. That's my first one. It's not. I need to find something else. Let me write my statement. Sophia, did you have something?
The angle of DBC is congruent to the angle of EBA.
Good. DBC is equal to EBA. Is that what you said? Oh, I thought you said EBC.
I just changed it to congruency.
No. It's fine. I'm sorry. I probably didn't hear you right. I thought you said EBC and DBA. What did you say? You said...
I said the same thing except it's congruent.
Okay, well then no, that's not it. If you're saying, are you giving me what's this is?
No, I'm giving you DBC and EBA.
DBC and EBA. Okay.
That should be said first.
Oh, well then he was right. I'm sorry. Noah, you're right. You're good. Jonah, you're right. Except I'm going to change it to the angles. I'm meaning angle 1 and angle 3. You're going to have to wait. I'm going to change it to angle 1 and angle 3. But Jonah, yes, you're right. I just didn't hear you right. These angles can get a lot. So my first one, I'm changing it to the measure of angle 1 is equal to the measure of angle 3. Okay, why am I using the 1 and the 3s? Because they're giving me those specifically for my angles, and I'm going to use that. Instead of getting all jumbled up with all the letters. Okay, so that is what's given, and this is going to be given. Okay, again, you don't have to write it down, just follow along. You can write it down after. Looking at the next step. Remember, I'm trying to prove that my angles are equal. I'm trying to prove that this angle is equal, and I'm trying to prove that this angle is equal. Right now, what do I know? Angle 1 and angle 3 are equal. Now, I need to add something else. I'm going to go ahead and state that the measure of angle DBA, I need to use the information that they gave me. I need to use what I'm trying to find in my statement so I'm able to find my answer. So the measure of angle DBA equals the measure of angle 3 plus the measure of angle 2. Do we remember what property this is? Or postulate? Not postulate. Yes, postulate. Do you remember what postulate this is? If I'm adding 2, it equals the total. This is from chapter 1. You guys have to remember these, yeah?
Addition.
Something addition postulate. What are we working?
Addition is an addition
Angle addition postulate. Just flip it around. You're good. So yes, it is angle addition postulate. Angle addition postulate, also known as AAP. All right, now that I know that, remember, I need to prove that the two angles are congruent. Now I'm going to go ahead and just change some information. Pay attention to how I'm going from 2 to 3. I'm using the information that we knew. I'm using the information that was given. So 3, I'm still saying the measure of angle DBA is equal to the measure of angle 1 plus the measure of angle 2. Can anybody tell me what I just did there? What did I do? Oops. What did I do? Can anybody identify what I did? How did I get from 2 to 3? Yeah.
You just did, like, since they're congruent, you just look, like, since they're symmetrical on both sides and they're congruent, just like flip the 3 over 1.
Yeah, but there's a specific word for it. There's a property for what I just did.
They're reflective property.
Not reflective property. It starts with an S. No, not symmetric. What is it? I just substituted. Okay, so look at what I substituted. Because I knew that the measure of angle 1 equals the measure of angle 3, all I did was substitute it. So for that one, I'm going to go ahead and write substitution. Okay, all I did was substitute. So now I'm kind of getting on the right path. I'm kind of seeing what I need to do. So 4, it's a little hard to see that 4. 4, I'm going to take that measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle EBC. And yes, this is still going to be angle addition postulate. I'm still doing the same thing. I'm adding those two angles to give me my total. Now I'm going to get my last step. Now I can go ahead and I just proved that the measure of angle DBA is equal to the measure of angle EBC. How did I do that? Look what I did. If these two are the exact same thing, I can go ahead and get rid of that. What is that called when I'm getting rid of that overlap? It's not law of syllogism. I need a property. Yeah. Good. Now what I did from getting to 4 to 5 is I used that transitive property. So this right here, this entire slide that I did, this is just more like a little snippet, a preview of next lesson, okay, of a proof. So you'll be given a diagram. This is more of a geometric proof. Do we have any questions on this? Do we kind of get the steps and we're using information we have or using what's in the diagram to find what's next? Does anybody have any questions on this one? Yes?
Do we need to have work like this on homework again?
So the homework is mainly going to be algebraic proofs. So yes, I still need to see the steps on how you're getting there. Yeah. Questions on the geometric proof? Again, this is for tomorrow. This is more for tomorrow. But your homework is the algebraic proofs, so those should be pretty easy. Your study guide for your test is already posted on Canvas. Your test is a week from tomorrow. Okay?